Yeah.
In this container, you get all that, so it's much more like you have to take snapshots, you have that full image and all that.
Okay.
It's just lighter weight than the
Okay.
because typical containers, you're running your app,
Right,
not
yeah.
running your operating system.
Right. Yeah, because it shares the underlying operating system. Interesting. Huh. Okay. Have you played around with Firecracker at all?
No.
See, that's something that a bunch of people that I work with are kind of getting into, and it's lightweight VMs. So, sorry. Okay, I should probably.
Yeah,
but yeah,
if I end up talking about containers or Kuber or I don't know whatever. Then maybe I'll try to cover all three, even though I'm really minimalistic. But I think a lot of people don't even know that it exists. So
Okay.
It might be an interesting topic anyway.
Yeah. No, that would be awesome. Yeah, we should do that.
I'll just say one or two admin-y things.
Sure. Yeah, that's fine.
Feel free to move the chips. I just figured we had some space to.
Kind of person that doesn't have a self-control with the bonus times.
Just shrink everything. This is.
All right. Thanks everyone for being here. We're gonna get things popping. We're doing a bunch of different stuff this month in terms of the Go meetup. Usually doesn't meet here, and you guys are here. So we've got a dual meetup tonight. We've got Seth presenting for the Go user group, which I'll let him talk about, and then we've got Michael going to present for the Python user group after Seth. We'll have probably a 5-10 minute intermission in between. Snacks in the kitchen. We've got pop, coffee, water. Help yourself, or I can help you as well. Beverage. And then right around the corner are bathrooms. And without further ado, I guess I should do like a little MC intro. I've known Seth going back like 4 months. So we go way back.
Yeah.
And he just got back from KubeCon. So he's a smart guy.
Where I stood at a booth and did absolutely nothing. So.
Knows much more about Go than I do. So I will give it to you.
Yeah, well, thanks for coming. Most of the regulars from the Go user group are here, all 4 of us. So, so if you would like to come to the Go meetup, come to the Go meetup. Maybe we can do like combined stuff more often. That would be fun. I will admit that from a Python standpoint, I know next to nothing. So I kind of always planned on coming and just sitting in the back and heckling, but that never actually happened. So. The other thing about this is normally at the Go meetup, we are pretty code intensive. We do a lot of like live coding and things like that. This is not going to be like that. So something completely different. It's more of me kind of thinking out loud, and y'all get to sit here and listen to it. So basically rethinking APIs, request and apply over distributed message bus. Is the general theme of the talk, and I guess we'll just dive in. I'm Seth. I work at Synadia. Full disclosure, we run a distributed message bus, so you kind of that cat's out of the bag now. But part of it, I've worked in distributed systems for a long time, and container orchestration, ops, those types of things. And so this whole idea of exposing services from that environment to the outside world has always interested me, and then working on a distributed message bus kind of had a different approach to how to do that, and so that's kind of where a lot of this thinking is coming from. So, agenda, just so we all know where we're going. Why are we here? Not in an existential sense, but what are we actually going to try and talk about? But I figured that was a dramatic way to start, so why not? And then a thought experiment. I guess we could take audience participation in this. I have definitely a direction I want to go with it, but it'd be interesting to kind of see if we kind of work through that together. We'll boil it all down after the thought experiment. Kind of what do we take away? See if there's another way that we can go, and then finally not write some code. I've written some code, but given that I was out of town all last week, this all kind of got thrown together. So hopefully the code works. We'll find out. So a few clarifications. API, what am I wanting to kind of box that in? JSON over HTTP. That's what I'm going to define as API. There's lots of, we can argue about that. But for the purposes of this talk, that's really what I'm talking for, because there's lots of other things that we could define as an API. REST. What is REST? Whoever really actually implements a RESTful API? I mean, come on, right? There's some of the typical get, delete, post CRUD type stuff over, paths, but unless you're doing like Helios or something what is REST, right? So, and still the payloads are usually JSON. gRPC, binary payload over HTTP2, but gRPC web. So if you want to access it from HTTP1, like a web service, you're going to have some sort of translation layer. Actually, we had Connect gRPC, which is an interesting sort of, it does gRPC web, it does just regular translation. But again, there's a translation layer there. What you're actually doing is sending JSON over HTTP, and it gets translated into either HTTP2 before it's forwarded onto the back, or with Connect RPC, they do like their own custom protocols around that. GraphQL, I am just going to classify that as a data representation and query. Again, we can squabble about some of these things, but I almost guarantee you your backend data sources are using something else. That's like the whole idea of schema stitching. You use GraphQL, it goes out, grabs your data, brings it back, and then condenses it, allows you to query it in a GraphQL. Unless you're using a graph database, which if you are, I'd love to talk to you because I've never actually implemented an actual graph database for storing data. But so clarification, that's what we're talking about. JSON over HTTP. So why are we here? Mainly, I want to highlight the Stockholm Syndrome, kind of name it and shame it a little bit. When we're putting together APIs, there's a lot of sort of traditional thinking that we kind of just thought patterns that we all just kind of fall into. Hey, I want to set up an API. Okay, I've got to do this. I've got to do that. And the idea is to kind of stop and take a step back and be like, do we actually need to do all of those things? Are they healthy? Are they maintainable? Like, let's at least put it out there exactly what we're doing, and then we can decide whether or not it's a good idea. Tell a story. That's going to be the fun part. We're going to kind of walk through. I don't know. You can tell me if it's a horror story or a fairy tale or a nightmare or whatever after we get done with it, and then examine possibilities. So again, I'm not trying to present any kind of dogmatic approach. It's more, can we talk about where we're at? So thought experiment. Meet Bob. He's very happy. He's also the extent of my graphic capabilities because he is supposed to build and deploy an aggregation service. Huzzah! What is an aggregation service? I don't care. That's not important. The point is he's building a service that needs to get deployed, and it's going to aggregate things. But it needs to have internal and external access, right? So it's got to be, he's going to have different types of users accessing it in different environments. It's a really important service, very important to aggregate all the things. So it has to have low downtime. So, there's lots of I don't know. That's kind of loaded, right? We've got HA and all those other types of things that are involved in that. And then management wants to know how it's being used. So obviously you've got to have observability. We've got to know if it's being hit really hard, if it's not being hard, all those types of things. So how should we do it? And I guess this is kind of the audience participation section of things. But I mean, I guess the exercise is just really stop and think. I have a service. I need to build it and deploy it. It needs to be accessible. It needs to be HA. It needs to be like, let's just go through the list, right? I will give us an assumption. It's going to be containerized, cloud native. I don't know if any of you, I mean, what does that even mean? Cloud native is kind of this shorthand for, stateless and containerized, run on some sort of container orchestration. So whether it's, some cloud provider or Kates or something like that. But so accessible, we have to have service definitions. It has to be accessible from within wherever it's running, right? So if it's running in a cluster, if you're running in Kubernetes, you're going to have service definitions so that the cluster knows how to route the traffic internally. If you've got something like you're pushing it to AWS Fargate or something like that, you've got, is Fargate the container service? Yeah, it's the container service, but then there's also some other container runtimes there. You have to have some way of defining how it gets traffic routed to it, right? So you've got to define that. But it's got to be routable, both public and private, right? So now you're talking ingresses. So now you've got the service definition, which tell the cluster or the containerization orchestration service how to route to it, or how to route the traffic. But now you have to expose it to be routable from both internal to the cluster and then outside the cluster. So you've got to have some sort of ingress, whether it's API gateway or, if you're using like an Nginx ingress in Kubernetes, you've got to expose the internal accessible service definition to an external route, basically. It's got to be discoverable. So now you've got DNS, whether it's Route 53, Most of my references are going to be AWS focused, so I've used Azure, Cloud, and GCP very, very minimally. So it's, yeah, like it or lump, it's going to be AWS references. So DNS, or if you run some sort of DNS server yourself or use Route 53 or something else, it's got to be discoverable. Now we're bringing in another service, DNS. Observable, traffic metrics. Hopefully you're running something that you can get traffic metrics inside your cluster. So Kubernetes exposes cluster metrics at the service level. If you're running Istio or some sort of service mesh, now you get really great metrics because you've got sidecars running alongside your services. But what about like your ingress, right? What about like Nginx ingress? Well, you can probably get stuff from that. What about ELBs, your load balancers that get into the cluster? What about CloudFront? If you're putting some sort of CDN in front of it. Now you've got all these layers, and you want to get metrics from all those things potentially. Maybe not. You've got layer upon layer upon layer. It's got to be highly available, right? So now we're talking load balancing. We're talking distinct regions if you want it to be cross region. God help us, federated Kubernetes clusters. I mean, yeah, highly available. Not too hard to do if you're just in one region, in one namespace, in one load cluster. You have your deployment, and you have three instances, and you're off to the races. But it becomes a lot harder. And then secure. So you've got different auth to Z, because remember, it needs to be accessible from within your cluster, potentially internal, but then it also needs to be secure from external. And then with Istio, you get that whole security in depth thing, which is great. But if you don't have Istio running, what happens if somebody puts a container inside your cluster, finds the service definition, and then just starts hitting it, right? Like now you have no way of checking those types of things. This was a very, very long list. It's definitely not exhaustive. Oof. Bob is no longer happy. And we didn't even bring up streaming responses yet. We didn't even talk about what happens if you're sitting on a browser and you need to, do WebSockets in? That's fun. So, yeah. So, could this, and again, this is definitely not exclusive or exhaustive, but you've got clients sitting outside your cloud provider. They're hitting DNS, going from the right to left. They're going to your cloud providers, maybe your load balancer, going through your ingress. Those hit your services. Your services have to hit your auth-to-Z service. They have to potentially aggregate their metrics on Prometheus. Oh, you've got that internal client that needs to hit it. Maybe you've got Istio running inside your Kubernetes cluster, but you got your Kubernetes clusters running your cloud provider. There's a lot going on. And remember, this is just an aggregation service. We just have a little aggregation service, and all we want to do is get it out the door. And this is what we have to do to get that thing shipped. And not quite as I mean, there's a lot of complexity in there. We're assuming it's a very large aggregation service. It's going to be hit from a lot of different places, but this is the type of thing that we're looking at. Could it look like this? And this is really kind of the crux of my thinking recently around API access. And again, remember, API is defining JSON over HTTP. So clients accessing your message bus, internal clients accessing your message bus, service accessing your message bus. No need for ingress. No need for, ingress to your message bus. No need for your service to have direct ingress. No need for DNS discoverability. No need for your routability, all of those types of things are hit at the message bus. So to boil it kind of down, what the thinking is, in that first sort of example we were talking about, every layer provides value, right? Whether it's a CDN, whether it's your load balancer, whether it's your service mesh, whether it's your containerization, whether it's like all of those things provide value. And I'm not knocking any of those types of things. They all do a thing. Every layer is solving a problem. DNS is your discoverability. Your container management is your orchestration is being able to sort of spin up, spin down, scale out your services. Your ingresses allow you to do a lot of things with traffic shaping, AB deployments, those types of things. I think what the real issue is, it's HTTP. It's a single client, single service, single response. That's fundamentally what we're talking about when we're thinking about HTTP. I have a client. It's making a request to a service to get a response. All of the other things, load balancing, HA, and again, we can argue about some of these things. I'm not dogmatic about it, but fundamentally, that's what's happening when I make a request. Now, WebSockets aside, that's kind of the common pattern. I need to expose an API, even gRPC. If you're HTTP2 and you can multiplex, you can mux your requests and responses, it still is a single client making a single request to a single service. and we try to dance around all of the other things. So another way. I don't want to change the deployment model. I don't really container orchestration, containerization, all that is great. I mean, I use Kubernetes just to deploy little crap things because it's easy. It's definitely probably way too complex. Not definitely, probably. It is definitely way too complex for how most people use it, right? They have a deployment. They maybe have some services. They have an ingress. That's it. And then they have Kubernetes for that. But let's give that. Don't change the payload or the data model. gRPC if you're using, or like protobuf, some sort of binary payload if you're using JSON. I don't really want to change the payload. I don't really want to even change the format per se. Request reply, kind of like HTTP. You have a request, and I spelled request incorrectly, and you get a reply. I don't really want to change that. It's really about changing the medium, request apply over a distributed message bus. And then I don't think I have another, I have just let's code. The thing that I kind of wanted to highlight is when you're doing that, exposing an API over a distributed message bus, you get a lot of the things that we kind of defined back on this other slide way back here, if I can come back. All of these things are kind of baked in. So service definitions, like your accessibility, that's really just once your service connects to your message bus, whether it's Kafka and you're using TOPIX or NATS is all subject-based. Once it's listening, it's essentially accessible, right? Because it's listening to those subjects. Routable. If I want to get access to it, I don't need to know where it lives, its IP address, how to get it. I connect to the message bus, I post on a subject, I get a reply. I post on a topic, I get a reply. It's routable, right? Like globally routable. It doesn't matter where the service is, it hits the message bus. It's discoverable because, again, I don't have to worry about, am I changing the name of my service and suddenly it's at service1.whatever.com versus service2.whatever.com. I just connect to the message bus. I hit the subject that I want or the topic that I want, and I get access to it. I don't have to discover it. It's there. Observable. The message bus can observe all of your traffic metrics. You don't have to worry about multiple layers of ingress. You don't have to worry about multiple layers of routing. Your message bus has all of the observability, and then highly available. Again, depending on that's a little bit separate from the message bus, but you can spin up and spin down. You've got, again, message bus have the concept of like queue groups and those types of things, right? Like you can scale out very, very easily. And then I will also admit that I'm kind of fudging highly available. Obviously, your message bus has to be highly available. So if that goes down, then obviously you're screwed. But so there is a single point of failure, I suppose, that you're introducing. But typically, if you're running like a massively distributed message bus, there's a lot of failovers, and you could also fat finger your routing tables too. So that's and then security in depth. The other thing that's really interesting about this is you have one surface area to secure. You don't have to secure your ingresses. You don't have to secure your cluster. You don't have to secure any of those types of things. You have one area that you can implement a security model, and it applies to all of the messages coming across the bus and access to those. So yeah, that is basically all I wanted to present. I have some code that kind of shows how some of this type of stuff will work in Go, but again, it's not very in depth. And then I guess maybe I would just like to have like thoughts, pushback. That's a bunch of crap. Message buses are horrible. Message buses are amazing. I love REST. What are you talking about? Like that would be something that I think would be enjoyable. But to start out, let's do this. I am going to do this. I'm going to spin up a message bus. Yes, I should be able to make it bigger. That's just we're not going to be able to. Okay, we'll see. Not a lot of screen space here. No, there's no such thing.
When you say the word
yes.
I feel like the times you said message bus, it kind of sounds like you're referring to queue versus you're kind of referring to versus.
Yes.
What exactly are we talking about?
Okay. So yeah, like Redis versus Kafka versus something like that. Like, yeah. So message bus, I'm thinking more along the pub sub line of things. So request reply is kind of what I would consider, not like, yeah, it would be how I would define it. I guess I didn't define that, but request reply, so pub sub. But more specifically with request reply, if you have something subscribing to a topic, being able to send a request over it and then get a response back right away, either on that topic or at an inbox specific to the client. So less streaming data and more request reply.
So
Yeah.
more like the event-driven architecture. Subscribe.
Yeah, yes, but not necessarily, right? So that's because I mean, it depends on what you're talking about for, so you've got, kind of the event-driven where if you're talking like a data stream where you're spending kind of the CQ, the command control separation pattern where you send command messages across the subject and you get replies, or you have side effects that are handled based on services. So you're separating the command from the data pattern. So that's one way of doing it, but I'm thinking even more basic of like, if I just have a service that all it does is respond to a request, right? Like a get HTTP request, right? Getting rid of all of the infrastructure that I would need to deploy that publicly and have it literally just subscribe to a message, and things can send a message bus, so a piece of software that will broker that, and then have others send requests over that and get replies back. Yeah, so that's kind of that's boiling it down to kind of where I'm thinking the lowest layer. But most of your message buses do a lot more than that, right? They're more streaming data type of a architecture. Yeah. So, yeah. No, great question. Any other clarifications?
I got
Sure.
two questions.
Yeah.
So does a message bus really not need load balancers or DNS?
Depends. So the short answer is, short answer is it depends. Yeah. So if you're talking DNS for connecting to the message bus, then yes, you have to have some sort of way of resolving access to the message bus. Once you're connected, I would posit that most full-featured message buses handle everything else for you, whether it's topics in Kafka or subjects in Nats. I send something over a topic or a subject that I have access to, and it handles finding how to get it to the services that are interested in it, and then passing the message back. So you don't need, from that standpoint, you don't need discoverability. You don't like DNS. You don't need to understand the routing of it. You don't need to even necessarily understand the security model gets limited because that's applied at the level of your connection to the message bus. So that's a lot of that kind of goes away, at least in my thinking. And again, I'm not dogmatic about this. This is definitely me thinking out loud of like, is it easier to do something without all of that cruft on top?
Yeah, I think what mostly comes to mind is like being a distributed message bus that would be able to accept messages on many different nodes, right?
Mm-hmm.
In order to
Sure.
take advantage of it being distributed.
Yeah.
You still have that load balancer to like choose an ingestion point to begin communication, even though you only need to connect once into it, and it handles everything else behind the scenes. The exact message bus is still distributed through the nodes of the message bus.
Well, it depends. And again, that depends. I don't know if Kafka does that. Nats, you connect to Nats, and it gossips the cluster, and it will tell you, hey, you're closer here, go there. And like, it's done. You don't have to worry about it. Like, you connect to your known NAT server and it says, hey, this is, I see you're connecting from the East Coast. Actually, I have a server on the East Coast. Connect to them. And then it knows when you're sending a service request, hey, I don't need to talk to, Seattle. I've got one in Boston that's listening, and it routes it to the closest service. So under the hood, and I'm assuming Kafka does something similar, and I don't know about like the AWS event buses, but I'm sure they're very similar. Like, that is handled at that message bus layer, right? The client that connects understands intelligently where, what's the closest connection is, and then the message bus itself should take care of, should.
That makes a lot of sense.
Huge caveat, should.
But I can't imagine.
Yeah. Yeah, absolutely. Yeah, no, I would, and I guess, again, I'm biased because of where I work, but that kind of seems like table stakes, right? Like your message bus should understand where your service is connecting from, understand when the clients are connecting, and do the right thing, and not make you as a developer have to be like, well, actually, I need to download the server list, pick the one that's closest to me, then connect, and then it should,
Okay.
yeah.
And then my other question, maybe you'll answer this with your code example, but we, at my previous job, we had implemented, there's this weird bridge that happens between synchronous and asynchronous when you try to go from the web to something that's asynchronous. And we had this happen. That's when we were trying to go to AWS step functions. We were using those as like the command response, and it worked fine.
Sure.
But it was slow.
Oh, okay.
It was like multiple tens of seconds of slow to do like a single request into it and then to pull the answer back out. And so
Ouch.
there were lots of problems.
Yeah.
There were a lot of things there.
Ouch. Yeah.
But so does that? Well, I guess maybe you'll just have to answer this part of it. But like, what does request response mean in like a message bus? Is someone like sending a message and like polling for the response, or like just leaving a connection open, waiting for a response to come back on the message bus? And does that mean that the client that's asking the request needs to be the one who maintains and polls to wait for the response, or is there something on the other side that is doing like the waiting, the translation between the synchronous and asynchronous for all of it?
Yeah. So again, I would probably from where I'm standing, kind of my thinking on it is that the message bus should handle some of that, right? So if you have a request and it's synchronous, I have a request and I want to reply, the message bus shouldn't acknowledge your request until it goes out and figures out the reply that it needs, and then pass that back to you. Or, I mean, I've seen other patterns where you send a request on one subject, and then you subscribe to essentially an inbox or reply subject, and then you wait there, subscribe to that for the message to come back. But again, that's like client sort of implementation details, whether it's handled on the server or if the client does the sort of inboxing response. But I would definitely think that should be handled by the message bus, not by, again, you as a developer having to say, okay, well, I need to like poll for a response. That's not, that to me, that polling a response is not request reply. That's like request and then pull an endpoint to get like to observe state change or something like that. That's not,
We switched over to, because it was super slow.
Oh, jeez.
It was awful.
Yeah.
But so I was trying to fix that.
Yeah.
So we changed it so that we were doing synchronous requests.
Okay.
It would just mean that the request lasted
Ever.
We would time out at 29.5 seconds.
Oh, jeez.
The weird timeout for API gateway.
Yeah.
29.5 seconds.
API gateway.
We had to do,
Yeah.
and that was all because we would call into a lambda, and the lambda function would call out to the step function. And the lambda was the bridge, so the lambda would hold the request open,
Oh, right. Yeah.
waiting for the step function to finish.
And then AWS would kill the Lambda. Yeah. Yeah. I mean, if I had that type of performance problem and I was thinking about how to implement that, it would definitely, you would almost have to go full async, right? Like, and do that thing where you send a request and then subscribed on a response, subject and waited for it to come back, or polling or something like that. But one thing that I do like in Nats is that the inboxing pattern is prevalent. And then it also does fastest reply. So if you have a distributed service and you're trying to get a response, it will broadcast on the subject. And then obviously all of the services that are listening on that is first one to respond. It sends back the fastest response and then kills all the rest, so that you essentially get the fastest one wins basically. So it's an efficient way of scaling out. You can just spin up a bunch of them, and then they all get the reply. The first one that's response, and then they have timeouts, like obviously on the RIP, so that they're all just trying to reply to the same message. And then you can do queue groups and things like that. But it's when you start getting to scale where you need to deal with just like a significant amount of traffic, everyone who's available gets the request and the first one to reply, and then they all just move on from there. So, yeah. Yeah.
Some themes around security and security around particularly enterprise clients. There's thousands, tens of thousands, and I'm not still talking. So I basically was, how do I make sure that requests and that later, someone wants me? How do I not have to structure scale from the bus to be able to keep track of people who may never come back? And I can keep going down that road for a lot of different types of security questions. Yeah. But I don't want to go down the wrong road that doesn't stay with them.
Well,
that's yeah. Right now, my head is all around a lot of what is. This is just what's going on with security models.
Yeah.
But each one goes on a different train depending on the access pattern or the
Yeah. So no, I mean that's a good question. The obviously when you connect, right, your security, when you connect to the server, you would have to authenticate somehow, whether that's MTLS or password, or NATS uses JOTS, so it's all JWT based. Your security model, your auth Z is applied at that point, both your auth N and your auth Z's, because you're authenticating when you connect, and then your authorization model is applied at that point. And so yeah, if you disconnect and then reconnect, you have to present credentials again, right? And so then it would be on the message bus to make sure that you're only receiving messages that you should have. I mean, and again, I suppose now if we're talking about ephemeral messages or persistence, right? If you have a message stream that's persistent and you can go back and forth within a certain message stream, do you have access to those? How do you control access to those? I think the inboxing pattern is what NATS uses, and it works really well because that inbox is unique to you, to your credentials when you connect. So if you have a request and you're waiting for a reply, it will send it back to that inbox. But if somebody else tries to connect, they don't have access to that inbox. So your replies are guaranteed to go to you if you for some reason get disconnected and reconnect that way. And then, yeah, it depends on, if you're doing topic versus subject-based routing, like that can, when you start going down, locking down access to your topics or to the subjects that you're broadcasting and replying on, then that's more of like a security design question, right? Can you how do you design those securely so that you can lock down people that are only able to connect? Again, NATS allows you to do sort of subject templates so that it can inject the user that you're connecting as part of your subject string. So if you say, I want to post on, chat.bob.message, Bob is dynamically populated with your user. So then you can say, hey, when this user connects, they only get access to publish on Bob, but hey, they can listen to everybody else's message, right? So I can always tell that Bob was the only one that published, but they can listen to all of the messages. They can see that Sally and whoever else published because they can listen to those, but they can't publish on it. So there's ways that you can lock it down, I think, kind of like that. Yeah, I don't know if that answered your question or if that was rambling.
It's both, but I kind of wanted to say, just as you're presenting, one of the members of your audience is that's the part that they're kind of key on, interested in as we get along.
Sure. Oh, well, okay. So the demo is very the demo is really just let's see. Okay. So that went by too fast. Basically, I created a NATS cluster. So this is a cluster of my message bus, and then let's see. NATS context, NATS select. So this is all very NATS specific. But let's let's see, now it's context select. I'm going to select a different context for my cluster. And then basically what it's telling me is I'm connecting to my local cluster. It's using my system credentials, which are it's an actual JOT and a seed, so there it uses ED 25519 keys under the hood. But if I could do things like NAT server info, and this is all going to be very small on this screen. I'm used to having a lot bigger screen. We can kind of see that we've got our Jetstream domain, which is just our persistence layer, but essentially it's giving us the server information, how many different servers are running, what the sort of the auth and everything is required for connecting to them. But it's basically it has insight into the cluster that's running right now. There's no subscribers, what the max payload is, how many consumers there are, how many subscriptions, how many active connections. It understands all of that and kind of has a complete picture. So this kind of goes back to the idea of observability, right? If you have the message bus is kind of the hub of everything. So observability is obviously very high because you can get access to everything. So the thing that I wanted to do here, I'll just go ahead and we'll minimize that, and so we can get a couple more. If we go to, and again, I apologize that I haven't done this. I didn't get this a little bit better. We'll go in here for that. I wanted to kind of, thing I wanted to demo was, I should have, there we go. Is that idea of having services that connect and then being able to understand, like load balance, get the request reply, all of the things that we had kind of talked about right from here. So the code that I wrote, again, super, super basic, global variable, never do that. Ignore that that's there. Never, ever, ever do that. Bad go. So we'll just kind of hide it. So yeah, main function, basically, Zap is just a structured logger. Here's where it gets interesting. I connect to localhost. This is where, hey, I need to actually know, obviously I need to know my initial connection screen. So this is where DNS comes in, right? DNS resolution. I have to be able to actually connect to my cluster. Once I connect, though, the client handles it. It understands, hey, did I connect to the closest one? Can I be rerouted to a different one? If the cluster changes, it gossips, new members of the cluster. So it's constantly kind of figuring out how the cluster looks. But I connect, and it handles retries, all of those types of things, right? In my mind, that's kind of, again, a lot of this is table stakes. If you're using Kafka or what's the AWS one? No, not SQS. It's the it's, I don't know what I'm thinking of. Maybe it is SQS, but it's their kind of their hosted Kafka. Essentially, they ripped off Kafka and they hosted. But anyways, that's kind of like if you're using any of those types of things, you connect and then that happens for you. So what we're going to do is we're going to create a service. And this is just really basic. It's a reply service. It replies to requests. We're going to give it a done handler. So if for some reason it stops, we're going to kind of gracefully stop. We're going to give it the endpoint. So we're basically going to say, hey, subject, listen to this subject, and then respond with this handler. Nats is all subject based, and it supports wildcards. So subjects are dot separated. So reply dot star dot me will get a request on, reply.whatever.me. It also allows you to do things like greater than, so you could do like reply.greater than, so anything after reply will come through. And then this is also where you can do things like, if you wanted to do actual like templating functions to say, hey, based on whoever's connected, fill in some of these variables so that the subject that it's actually listening to is appropriate. The credentials that we're using, again, with Nats, it's all JOTs, right? And the reason I like this is mostly because we can embed metadata in the JOT, so actual auth-z type things, permissions, but then because it's signed with keys, we can create revocation lists, we can we can create signing keys so that you can have a bunch of signing keys on the JOT, and then anyone who connects with a key that with a credential that's signed with that particular key can get access. It'll do scoped signing keys. So if you want a certain amount of permissions applied just based on the key that was used to sign the user credential, you can do those types of things. It's a really flexible authorization model. We also it does username and password and some other things like that, but that seems really, really not very good. So then we add the microservice, and that's about it. It adds the microservice to the client. So we hand it the actual client and our config, and that's it. We have a service that basically listens on that subject and then replies. We don't have to do anything else. We don't have to, we can, but we don't have to. We don't have to expose our service. We don't have to deal with routing. We don't have to deal with making it publicly accessible. We're connected, listening on the subject. If somebody else connects, it will be routed correctly. So that's kind of what I wanted to show here. So we have that. I built it earlier, so we'll just go build it. It's there. If I do if I start this up, it's just really hard to see. So you can basically say, look, it's connecting to NATS, it's registered the microservice, and it's ready. So if we do a NATS context ls, I'm going to go ahead and switch to that context that's the credentials for that particular. We can see that the microservice is connected, the reply service, and it's the ID. Now, if I go ahead and do that exact same thing with more of these. So I want to fan out. It understands that now I've got 3 of those services, the description, the request, the reply, or what the service name is, and the version. I can even do interesting information about like NATS, micro, what do we see? Info, I think. About the particular service. So it tells me, hey, this is what it's listening to. It's got 0 requests, the processing time, what the average processing time is, where it started, how many errors it returned. Like, it has visibility, and the cluster understands this. So from a metrics and a visibility standpoint, I can get all of those things. And then let's just go ahead and send a request now. Let's go NATS request, the subject test reply. We'll just do reply.to.me, and we're going to pass an empty body. And we can see this one over here on the right is the one that was received the message. And we sent the request, and we got the reply with a round trip time of incredibly small because I'm running locally. And now we can see that we have 1 request, and basically we get all those stats. But the really interesting thing is if we want to start hammering it. So let's go. Let's start, just send a bunch of requests. The message bus is load balancing. It's deciding which one is ready to return. It's sending all of those messages out, processing them, getting them back, and it's handling all that for me. It's handling the routing. It's figuring out which one is ready, which one is the closest. If this was like more globally distributed, it would actually figure out which one is closest to me, not just available, and handle it, route it intelligently. And if we do the reply, then we can see, obviously, you've got all those requests now, the average response time, and all those types of things. So this to me is way more interesting than HTTP APIs. Like, way easier. Once you have this infrastructure set up, being able to deploy a service like this, obviously this doesn't do anything interesting, but like this is not very much code, and you get all of the other things baked in. And then depending on what you're doing with your message bus, that was obviously request reply. Most message buses will do data streaming, like message persistence. They do, NATS does KV, NATS does, MQTT, it does object store, it does, like, there's all of this. This is definitely an area where there's these message buses, these services are building out their what they offer. And it's only getting more compelling, right? Like, you could have a microservice that also uses the exact same message bus to do key value store, right? So if you needed like Redis, just use your message bus. You're already connected. You already have your permissions, right? If you need to do object store, you need to do streaming, right? Stream processing, those types of things. All of that's built in, and you don't have to worry about all of the extra cruft kind of around that. So yeah, good idea, bad idea, I don't know. That's kind of, again, it's just what I'm thinking, whether or not it's actually, I just think we should just replace all the HTTP APIs with this. So that's where I'm coming from.
Is there a big performance difference between using method bus versus traditional like request response through HTTP?
Again, it depends, but typically no. It depends on your cluster topology and where it's at. So at Synadia we have NGS, which is like literally a global supercluster across all the regions and all the cloud providers. And again, it picks the right service that's closest to you. So your responses are, it's TCP, it's routed to the cluster. They have direct connections to all the different servers, picks the closest route. So when you're talking about, there's your CDN right there, right? Like normally you would have a CDN, we want the request to go to the closest service. The cluster handles that for you. It sends it to the closest service for your request to reply. There's no caching layer in there, so that was definitely something that is not part of this. But yeah, then you have CDN, your load balancer. If you're going into Kubernetes, then you've got your ingress, then you've got your firewall rules that route your traffic to the actual node and then the actual pod on the node. And so you've got all of those layers that you don't have with this. So all of those network hops are gone.
Yeah, I think you would see, let's do reasons, but I do think skipping all those extra layers would have, noticeable performance gains as well.
Yeah. I mean, and that's kind of why this has been rattling around in my head. It's like if this seems operationally much simpler, and then performant, and then also the security model is much more contained, right? I don't have to worry about leaking anything at any one of those layers, or somebody getting behind my ingress in my cluster and now accessing it in a way that I didn't anticipate, because they can't. They have to go through the message bus, and that's where it's locked down. So, yeah. Cool. Well, I've talked long enough. Sorry to put you through that. Thank you for listening. Yeah, if you have questions about message buses or Go or anything, yeah, hit me up. Otherwise, come to the Go meetup. We'll write some cool Go code. More than this. Normally, we actually do more coding, and it's more like live coding. This was very much just me talking at you, so I appreciate your patience. But yeah, I guess that's it. Thanks. Oh, yeah. Yeah, so we normally meet over at Fellow Co-working. So it's just it's right behind LaserQuest, the old LaserQuest building. It's the old Washington Cracker Company building. Usually we do 5:30-ish to 6:37, whenever. So we usually meet a little bit earlier. Second Tuesday of the month, except for I was gone at KubeCon. And then it's really, up and coming, I think we're going to have, containerization, container management, all those types of things. It's more, so Go is definitely the focus in that. Most of the stuff that we play around with is written in Go, but it's also less kind of like this. It's nominally Go because the message bus was implemented in Go and the examples are Go, but it's kind of like, it doesn't have to be strictly Go. Like what I think last meetup we did, embedding web UIs in Go binaries. And so, yeah, we had a great talk on like GraphQL, or gRPC, and like a single page app embedded in a Go binary. So you just ran the Go binary and then you get a website and you interact with it. And I mean, it was super awesome. So we normally do stuff like that. I think coming up, we're going to do containerization, kind of container management, like different strategies for that. A lot of the DevOpsy type tools are written in Go. So that lends itself. Beyond that, I don't have a plan. If you have something you would like to have talked about at a Go meetup, come join us. And I mean, there's not very many of us, and we're pretty flexible. So if you have some burning desire, I think we did Go routines, kind of the green thread model in Go. And then, yeah, we've done different build ways and build tooling and stuff like that. So yeah, but come check us out. And I'll come check out the Python meetup, sit in the back and heckle, since I know nothing about Python. So I will learn lots tonight. But cool.
Cool. That is 6:34. Let's meet back right here in 6:45. Yep, 11. Give you an extra minute. Yeah, thank you.
Cool.
Send it back to you.
Yeah.
I don't know if
Is this water from me, by the way? It magically appeared, but okay. We got the best host. All right. Testing. Testing. 1, 2. Testing. Exit. T code presentations. Bug 14. Let's see, create a few, create a flip, and then. Okay, there's that. Git pull. And build. Oh, that's hilarious. What happened? Where's my environment file? Let's do that.
Is that a carbon?
Huh?
Is that a carbon?
Yes, X1. Redis. Hang on, I'm plugged in.
Are you duplicating or extending?
Duplicating.
Make any more radio innovation? Can I unplug it?
Sure.
And just let me know when you're ready as I'm screwing up your display.
Hang on. 3, 7, 9. Sorry. Anything?
I'm not getting any input.
Huh, interesting.
Are you able to duplicate even just for a second so I can verify?
Well,
Or I also have a USB dongle if you want to try that.
unify outputs is what I did. But I'm noticing that I display configuration, I'm not getting anything to pop up.
Let me grab.
Sure. Could also try just rebooting. What are we looking for? USB-C?
Yeah, is that okay?
Maybe. No, I'm still not getting anything. I don't know. I can try rebooting. Sometimes that helps. No, you're fine.
No, I don't know.
Gave me just enough time to realize that I accidentally deleted my environment file and had to rewrite it.
You've got our Wi-Fi, correct?
Yeah, I'm connected until it's at guest. Yeah, that should be fine. I'll reboot.
I wonder if it's like, is this like not sort of a display-ish? It's like going into a device that it's not actually
Okay.
display, it's like a display capture thing.
It also could just be my computer's acting up. I don't know. I feel like it can be hit or miss sometimes on Linux.
Are you able to Actually, is the collar gonna rub against the mic? It's on the outside.
I don't think so.
Okay. Sometimes if you like put it in the right spot, it just like.
Could you hear me fine? Like, was the audio fine?
I'll let you
Okay.
know if it. I only listened for a second.
Okay. In here now.
I wonder if now it's trying to output to this.
Maybe. That would be hilarious. What's that? F7, F2. Try again. Yeah. I'd say worst case scenario, if you got a computer that works, it has Docker on it, I can just clone Maribo on your computer. I don't know. Of course, then I don't have NeoVim. I don't have my editor.
Little handicap. I mean, I'm not like if we can't get the stream, that's fine. But I also need to be able to get it to
Right on the projector. So.
So you can Wi-Fi. People have done it with iOS.
Thanks for presenting again.
Yeah, no worries. If we can get it to work.
Yeah. Okay. Maybe. Should we go plug it back in now?
Let's get to the desktop. All right. How about now? It's weird because we can, I don't know, try a different.
No.
Yeah, we had that's what we tried to bring in.
So what are we actually, what's that cable actually plugged into? If we, okay.
Say.
And where does this go?
This goes in my computer,
Okay.
which wirelessly is connected to that.
Okay.
And then is also pushing up to YouTube.
Okay.
We can also try, so I can also give you an HDMI that'll plug you straight into the router or the
Projector.
projector. We'll just lose the stream, which at the end of the day is what it is.
Sorry, guys.
Yeah, I really.
Yeah, I don't know what's going on.
I don't
And I don't know if I'm going to be able to put the bug in 30 minutes.
So it's this guy right here.
I don't know. I think it's.
Okay.
Yeah, just around, yeah.
You really have.
Yeah, there's only one on this side. So. Oh, that's not one. Still nothing? Not even that? Yeah. No, I unplugged it, so it's not.
That's exactly. Do you want to try the dongle again?
Sure. No, that's,
Is there like a different, like a
I honestly,
top driver, like the Wayland versus the
not that I'm aware of. Not on this computer, at least. Yeah, it's annoying. It's like it recognizes it, but then it doesn't know what to do with the signal. I don't know what to tell you.
I can offer you a MacBook.
Could we just set up like a Zoom link? And then like you share your screen with the projector and then I
Yeah. You do you have Teams?
no. I Zoom. I could do Google Meet.
Yeah. Can you? I don't have a Zoom license, so I can only do like 40-minute meetings. But
Well, we're already under 40 minutes, so we don't care about that.
okay, I can send you a link.
No. We're going full hack, and he's going to share me a Zoom link, and then I'm going to use that. And he was like, well, we don't have a license, so that's not going to go over 40 minutes. And I'm like, well, we don't even have 40 minutes left, so it's fine. I don't know what's going on. I haven't updated my desktop environment in like months, so maybe I'm just running some sort of.
You don't want to lose your icon version.
Huh? No, I don't care about that. It's just I just haven't done it in forever.
Well, talking to one never did.
Yeah, I'm getting there. You send me a link on Discord? Okay. Well, he asked if I use Microsoft Teams. I was like, no. Do not join with audio. You got to enable screen sharing. All right. Hacks for the win. Bug 14.
This is a great solution to connect two computers that are 20 feet apart.
Yeah. We'll be fine. Is this mine? Where's my presentation?
You are.
Yeah, I know. That's fine. Here, I'll stop the share really quick. Actually, maybe I don't.
This actually looks good. Premium
Hang on, I got 2 Wi-Fi. Yes, it's me.
Oh, no. Can you get a car 55%?
Just give it time. They're starting to sweat. All right. Slideshow. From beginning.
Seth is obliterated APIs.
Okay. Yeah. All right, I think we're good. Yeah, there we go. Got to use it for something useful. Make myself feel good. Can build. Hang on, I got to build a bunch of stuff.
Yeah, these look so cool. Oh, they have more pins on the side.
Okay.
Ready?
Yeah.
All right, folks, let's just be.
We made it.
Yeah. We told you at 7 o'clock. Just to give you a little input into what we've got going on. We've got a Zoom call between this computer to the 20 feet away computer to project to this and go to YouTube. So, but I think it'll work great. Yeah, this is the Python portion of the Python user group. We've got Michael speaking again after he crushed it with the C Python stuff. So I'll turn it over to you, Michael. He's a PhD. That's my plug. I mentioned for Seth, I think you missed it, but I said Seth had gone to KubeCon, so that's, we go back, we also go way back about 4 or 5 months. So.
It's okay. My expertise is in something so small that it's a rounding error. So I'm chemistry. So yeah, exactly. It's like I'm as dumb as you guys out here. So sorry, that was mean. Okay, so my name's Michael, and I'm going to be giving I'm just kind of an overview, more beginner intermediate talk on the landscape of Python microframeworks in the Python programming language. Typically, when we talk about microframeworks, we're focusing on web frameworks that give us the minimum functionality necessary for spinning up web servers. And when we talk about web servers, as we talked about earlier, we're talking about stuff like REST, RPC, etc. These are frameworks that don't provide anything like ORMs, templating, logging, stuff like that. It's really just a strict web server that you can spin up and make requests to, get responses from, and we're going to be talking about a few of the microframeworks that are available in the Python ecosystem. Most of these microframeworks are focused on serving what we refer to as RESTful web servers. RESTful web servers will use HTTP verbs to perform straight transfer operations like a get, a post, a patch, options, stuff like that. REST is typically thought of as a hypermedia-oriented access protocol, where a lot of the proponents online will talk about this in terms of being where hypermedia is the engine of application state. And over the course of the last 2 decades after Fielding's initial PhD dissertation, which gave us the definition of RESTful services, we've kind of taken that and massaged the idea of being able to communicate this over JSON. It's not technically hypermedia, depending on how evangelist you want to get about it, but it is what it is. We use it anywhere from doing straight remote procedural calls all the way up to actually full REST API design. So in the Python framework, there are a few web frameworks that are most popular nowadays. The top one is Flask. The second framework is actually Django, but we don't really consider that a micro framework because it gives you all of your admin tools, your authentication, you get stuff like that. You can go through and actually build out full stack web applications in Django. So we don't really consider that a micro framework. And then one of the more recent ones is FastAPI. We'll get into the conversation of asynchronous versus synchronous web frameworks in a little bit. And then just for good measure, because it's the one that we use at work, I included CherryPy as well. So we're going to be going over the top 3 web frameworks and how you can actually go through and set them up and actually get them to talk with various clients. So a common architecture for REST services, specifically for being consumed by front-end clients like JavaScript single-page applications, is using this RESTful architecture where, man, I wish I had my laser pointer. Where, for example, if we define a JavaScript client that is able to make a REST request where I like a get, a post, a patch to your Python REST service, it's going to be able to return a response based off of the request that came in from the JavaScript client, where the HTTP, for example, down here, we have an example for the JSON REST response of HTTP GET, where you might include some JSON referring to the resource itself and some of the items, and then it trying to get it a little more hypermedia oriented, actually providing those URLs for the individual items that you might expect for this REST service to be able to allow you to discover. So in Python, when we typically talk about web frameworks, we usually so there's actually 2 pieces to Python microframeworks. There's the web server, which is either WYSI or ASCII, which is the actual piece of the actual subroutines that are actually sitting on the port and on the socket, waiting for waiting for requests to come to the computer, and then you have like a web framework that your web server is going to be able to load in, and if it adheres to a specific protocol, any sort of WYSI application will be able to be loaded by the separate web server, and this allows you to decouple actually listening on the socket to actually being able to handle the HTTP request. So I went out and wrote a demo application for those three microframeworks that we're going to be talking about for Python. This is kind of the setup that conveniently you get to ignore if you're using one of those. Yeah, exactly. So what we ended up doing, and we'll actually get into the code and actually go through debuggers and how to actually like write this out, test this out, and et cetera, is we have a service that's actually allowing you, or we have a service that is responding, or we haven't, let me start over. So we have an Nginx reverse proxy that is sitting on port 80 and port 443. And depending on what kind of request you make that, it's going to route that request to either an app that's actually just serving statically built JavaScript for the client to render, or it's going to route that forward to one of our 3 web servers, either the CherryPy, the Flask, or the FastAPI. So all 3 of the web servers are designed to do the exact same thing, which is basically act as a stateless mechanism for being able to access your database. In this case, I'm just using Redis because I didn't really care. And it's just trying to make things easy. Redis is storing 2 pieces of information. This is just a very simple demo in terms of like items that you can store in a database and then the descriptors of a particular item. So Redis actually has 2 pieces. It has a list of item IDs, and then it has a basic, well, I'm actually using a hash map, but no, I'm actually not using a hash map. I'm using key value store because in Python, some of the Redis has a few limitations in regards to like what you can actually store in the hash map that's Redis specific. For example, you can't store Boolean values in a Redis hash map, which is kind of annoying. So if you just dump it into a JSON string and store it as a value, you can get around stuff like that. Again, I don't really care. So 3 web servers all talk to the same database. We should be able to just query one at random, or if we set up our client to allow us to pick a specific framework to make that request to, and then Nginx is sitting in front and actually going through and being a reverse proxy, depending on what kind of requests we're sending along. In terms of testing, one of the things that we have to be mindful in terms of test-driven development for these frameworks is trying to figure out how to actually build a testing framework that sits on top of your framework, on top of your micro framework, without mocking too much of the I/O for the particular framework. So we have a Docker file that's going to allow us to grab the image of one of the frameworks, and then on that Docker file, go ahead and install all of our testing, our testing requirements, and then execute into that Docker container and then run our test suite. And so that's what this is. So if we can, so this is just a Git repository on my presentations. On my presentations repository on GitHub. It's available if you ever want to go and clone it just to see what any of this looks like. And let's see, Docker PS. So we're going to go ahead and restart everything. This is just going to spin everything up. And if I were to go to a browser and go http local.Spokane python.com, if this works. Okay, so our browser made a request to the Nginx reverse proxy, and that forwarded it to basically what's running in the background in one of the containers is a dev server of npm. So we can make changes to the JavaScript code and it'll reflect it here. But for now, if there's a dropdown at the moment, that's going to allow us to select either any of the frameworks. For example, this is CherryPy. We can go ahead and give it a name, this, description, that, make a submit, and it doesn't work, obviously. What happened? Response is not equal to 201. Okay. Man, that's a bummer. Is everything up? FastAPI, Flask. Is it all of them or just one of them? Sorry, give me a second. Give me 1 second. So one of the things I noticed, 6379, I'll just write as password is pass, and then default is 1. Well, this was all supposed to work, but as looks like the demo gods have decided to give me a new one. Give me one for my money. While I'm trying to debug that, we can try to, let's see, test FastAPI. Actually, let's go ahead and build that. So while all this is rebuilding, hopefully that's just a build issue and we just rebuild it and it works again. One of the aspects of building Python web frameworks is going through the testing process and making sure that you're able to do some sort of the operations that you would expect for a JavaScript client to actually do against your web service. Most of the Python microframeworks have some sort of built-in test client functionality that you can hook into. For example, with the here, let's actually start with the Cherry Pie one, for example. Different frameworks will have different mechanisms for hooking into the web service itself. So for example, Cherry Pie is going to allow you to make GET requests and then specify the method based off of the test that you're running. And you can do items like you can get, you can post, and then, sorry, I'm getting a little flustered because I'm kind of annoyed that this isn't working. Clear. Test API. Well, at least that works. Okay. Let me go backwards a second. Okay. So each of our web frameworks has some sort of built-in functionality for actually spinning up a web service that listens on a port. Depending on whether you're using Cherry Pie, Flask, or FastAPI, there's usually some sort of mechanism that allows you, if I don't delete it, to set up your server, which in case of FastAPI and Flask, there's usually some sort of app that you specify. And then you have the option of adding routers or blueprints to this app that allows you to specify routes routes relative to the router that you're mounting to. Then typically what you do is you hand this off to the web server framework. In this case, I'm using UVcorn. On Flask, you use something like, you can use like GUnicorn. Cherry Pie has its own built-in web framework that actually sits on the port and actually listens to requests coming in from a different source, and passing off this app to be run by the web server. And in this case, we're specifying a host, we're specifying a port, and then we're allowing that web server to take requests in from some client and then serve that accordingly based off of the framework. Each framework allows you to define methods, those RESTful, those HTTP verb methods accordingly. For example, this one is for FastAPI. It allows us to specify a router, and then based off of that router's prefix, for example, I would hit the API endpoint, api.spokanepython.com/. The FastAPI is going to redirect you to this method if it's a GET request, and it's going to return as a JSON blob, or not as a JSON blob, as JSON text, the response that would then be consumed by the API. In this case, we're returning a dictionary that includes the keys self and then the keys items, which each item is then referenced, is given its own URL as a reference to the next item. Accordingly, to make a subsequent HTTP request based off of the item, it would route you to this page because your HTTP route would be api.spokanepython.com/item and then / the unique identifier for that item that would be parsed in through here by your framework, and then it would just return the data that is actually associated with that item stored in the database. So for example, if we were to go to where that GET function is defined, what it's doing is it's just going into Redis, it's loading the database, and is returning a dictionary that's going to get turned into a JSON response by the web framework. I feel like I'm kind of all over the place just because of my demo mishaps. Does anyone have any questions that I might be able to address? Yeah, what's up?
So this kind of back to the testing. When you say it mounts web server, is it just does it actually like provision it like a TCP port and then runs natural?
That's all It depends on the web framework. Typically, I think with Flask and I think with FastAPI, I don't think it's the case with the FastAPI because it imports a HTTPX. I think with at least Flask, it's just importing the app and then calling the method accordingly.
Worry like about if you're trying to run tests or CI/CD or anything, you don't have to worry about port allocation or options or things like that if you're parallelized.
Not that I'm aware of, at least for, and then it's gonna vary by framework. I think Flask API does, but Flask doesn't. It's gonna depend on the framework, and I don't think CherryPy does either. Yeah. All right, let's see, Docker, yes. Give me 1 second to see Docker. Yeah, I don't know what's going on with the demo, but it is not working at the moment. That's a bummer. Okay. Well, part of it was the part that has to do with testing. So if I go ahead and hit Docker PS, one of the things that you can see is that in our Docker environment, we have 3 containers spun up, one for CherryPy, one for Flask, and one for FastAPI. One of the things that you can do really nice is if you can specify build arguments before the actual call from a base image that layers will be built on top of. So one of the things that allows you to do is you can, if I'm not breaking my setup in the meantime. One of the things that you can do is you can specify a framework and then specify the name of the base image that you want to build on top of, and then you can install all of your testing infrastructure on top of that image. So one of the things that you can do. So what that looks like is if I go to this command utility that I have, you can specify the build argument as a framework, or you can specify a build argument and then build a container on top of one of your API containers that you specified. So we can go command build flat, or let's do CherryPy. Oh, there goes right. Let's build. And what that's doing is it's loading in the Docker file and then passing in that as a build argument. And then you only need one Docker file for building all of your test suites on top of different containers of space images. So we do that. And then since we're building the CherryPy API, we'll go ahead into this test suite And we'll just drop in right here as PDB. Give it a second. Okay, there we go. So now we're inside this testing container, and then if we do PyTest API or code API, what we're doing is, so PyTest is a testing framework that typical, the Python projects typically use for testing, and what PDB is a debugger that'll actually stop the execution of the Python interpreter inside that testing framework. So typically, this is the workflow that you see with Python projects, because one of the things that Python doesn't give you is static typing. So there's a question of, okay, what is my variable actually at a particular point? There's some issues where that you can have where when you're developing against Python projects, where you don't actually know what's available to you at a given position, at a given state of the interpreter. So one of the things you can do is drop into the debugger and say, okay, what are the options for off the self object? And these are all the methods that are available for your testing. And one of them is self.getPage. So this is a function that's actually going to go and call your web server. In this case, if we go self.getPage and we hit that items endpoint, it's actually going to, so obviously our web service works, but for some reason, like reverse proxy manager, again, maybe you shouldn't be handling that, I don't know. You can actually go through and hit the web server, it'll respond 200 OK. In this case, it's responding application JSON, it's a cherry pie, and then the body, self.body, is that response of the api.spokanepython.com. In this case, there's an extra slash for cherry pie to specify which framework you're hitting, and then your items. In this case, since we haven't added anything, there's no items. If we were to step forward a little bit in our debugger, you can see that on this line 29, we're actually hitting get page items with a post, and then we're passing in what I was trying to do on the JavaScript application, a dictionary with the name this and description that. So one of the things, so if we were to go back and hit that same endpoint again, get page items. Now our response is saying that, okay, the items that we have, we just added a new item from the previous post. So that's it in cherry pie. We could do the same thing. Let's do FastAPI. We're going to do the same thing. We're going to go hop over to the testing framework inside FastAPI. And it's going to look a little different. That's not what I'm looking for. Where in this case, instead of giving you a class with a bunch of methods that you can call, the typical expectation is to build a test client and then yield that using PyTest. And then inside your testing framework, let's go ahead and drop a PDB in here. PyTest API code API. So now we're in the Flask, the FastAPI test suite, and we can see the response that we get from making that client call. Response.text. That was that post actually. So we can do client.get again for that /items endpoint. We get a 200 OK, and if we get the text off of that, we see something similar. A lot of the expectations when it comes to what a microframework can give you are very similar across microframeworks. You know, you can do the same thing in CherryPy that you can do in FastAPI, you can do in Flask. At the end of the day, microframeworks are all kind of, we're just trying to do the minimal necessary work necessary for actually setting up a web server and allowing clients to connect to our web server and then route that somewhere else in our backend, whether or not we're pushing the request off to a queue or a message bus, or just reading the database directly and sending a response back directly. the whole ethos behind a microframework is the minimum necessary functionality that allows you to do that. So that's all I have for today. Sorry, my demo didn't go as planned. There was a whole JavaScript functionality that just isn't working at the moment. I don't know why, but that's what I got. And if you have any questions, I'll take them in shame. So,
I guess.
yeah, what's up?
So,
No, you're fine.
with it actually, they implement HTTP then, the microframeworks. They just listen to TCP. I missed that, what you were saying. They actually
Okay, so
run their own embedded web server, or they're expected to.
So the server is the UV-corn, the G-unicorn. That's what's actually sitting on the port and actually listening for the TCP connections coming in. And then there is an interface expected that both the server and the application adhere to that allows data be sent from the server into the framework. This is one of the things that I don't really care about when it comes to discussion of Python frameworks. Is like, oh, which one's the fastest? Well, it depends on what server you're running in. Are you running on G-unicorn? You're running UV-corn. It's like there's a whole second aspect to that request response cycle that nobody really cares about. It's like, oh, FastAPI is the fastest, or oh, CherryPy is the fastest. You know, you can run Siege against any of these, and they're all returned about the same speed. So because there's a whole extra aspect of actually sitting on the server and listening for TCP connections. It's like, okay, are you just gonna forget that? I don't know. So. What's up?
So I agree that the whole speed thing is like, well, how much does it actually matter given it's not new?
If we really cared, we'd be writing everything in Rust. But
yeah. But if we sort of take that consideration, what are the other considerations for choosing one of these frameworks over the other? Is it primarily just personal preference or comfort or whatever your team is doing, or what are the pros and cons?
Well, there's always probably the most important is inertia. If your team's already in a micro framework, you might as well just stick with the micro framework that they're doing. Some of it comes down to design philosophies behind the frameworks development themselves. For example, let's go and look at this items endpoint. It looks a lot different than, for example, in CherryPy than it does in FastAPI, where let's see, FastAPI, what was it? Items. Where here's the route that FastAPI is going to call versus here's the route that CherryPy is going to call. They both return the same thing, but the design philosophy behind the framework is much different. In CherryPy, for example, you're actually mounting components. You're mounting classes on top of classes and then handing that object off to whatever's going to actually run the server. In Flask, you're mounting blueprints or routers on top of your base app, and then decorating then encapsulating that inside an enclosing function, and then handing that off to like UV-corn. So a lot of it just comes down to design philosophy that goes into the frameworks themselves. Some of them are pretty similar, like Flask and FastAPI are pretty similar. CherryPy is a little different just because of that method dispatch versus the function dispatch. Another consideration that I didn't really go over here is like whether or not you care about the async IO development model for Python. There's a whole ecosystem around what's the term? It's cooperative multitasking, where instead of running everything on threads that are just blocked randomly, we're going to run our programs in a manner that allows us to await a function call instead of just randomly blocking and saying, okay, I'm going to hand off the ability for some function to execute to some other subroutine that's also executing at the same time. So I think Flask is more on the WGSY side, and FastAPI is more on the ASGI side in terms of being asynchronous versus synchronous. So you got considerations like that. So I'd say those are the three main differences between the three, where Flask is your WGSY, FastAPI is your ASGI, and then CherryPy has a different mounting mechanism that allows you. It's still WGSY, but the dispatch method is different. So.
Thank you.
difference if I chime in is FastAPI. I don't know anything about Cherry Pie, but at least between Flask and FastAPI is if you want to take advantage of like modern type checking in Python, FastAPI is different.
Yeah, FastAPI is a better way to do it.
I don't know. I don't think Flask takes much advantage of that.
Not that I'm aware of. So.
How do they do middlewares? How does the middleware affect like the call? Is one easier than another, or do they? I'm assuming they all have fairly hook in.
Flask and FastAPI operate more on the model of encapsulating, like of wrapping functionality. Cherry Pie is more of a message bus where it gives you specific spots in the request response cycle that allow you to hook into how, when's authorization going to happen. It's going to happen before my method actually gets called versus like FastAPI, you're going to wrap that in decorators and stuff like that. Mm-hmm. Yeah, Flask and FastAPI are very decorator heavy. Cherry Pie is more, like I said, it's more of a message bus.
Thank you.
Yeah, appreciate it. And I'm guessing 5 minutes later, I'm going to figure out what went wrong with my demo, and be like, huh?
It's not a force thing, isn't it?
I don't. Was it? Well, cores is usually what throws when.
I mean, in the browser, it's the same origin.
I thought I had that all handled, but I don't know. It's always a cores error.
I'll throw out a couple updates while you're taking a look at that
Sure.
before our Zoom link runs out. Yeah, just quick updates on stuff coming down the pipeline, really between now and the end of the year. This month, due to Thanksgiving, we met on the second Tuesday, and that's why we combined with the Go user group. I think next month we're actually going to meet on the first Tuesday of the month to keep the train going of screwing up your schedules. The plan right now is to meet at Vega Cloud in Liberty Lake. Their CTO, I think, reached out to me. Did you figure it out?
Yeah.
What was it?
Firefox, and it's I had a self-signed certificate from HTTPS, and Firefox wasn't allowing connections to go through until that was addressed.
Oh, here, I'll say one more thing, and then if you want to show some of that.
That's fine.
So plan on early December, and then you can forget about Python for the rest of the holiday season.
Hey.
In Liberty Lake is the current plan. I don't know what the topic will be, but they're going to talk about some of the work they're doing at Vega Cloud. I think they're sort of like their own cloud infrastructure is their sort of their product. So they'll talk about that a little bit, and they do a lot of Python. And then the other thing is this Friday at 8 a.m., according to email chain between David and Seth. Is that still good?
Yeah.
Still good? Okay, so yeah, at the last Coffee and Code, we kind of talked about pulling together a project for something we're calling Spokane Tech, which will be like a website or a one-stop shop for people to go and see all of the tech events going on in Spokane. So your Python, your Go, your C#, your Java, if anyone used that anymore. I don't know. Just got to throw a little out there. Actually, I'm using Java right now. It hurts me, to be honest. It's a little tough.
Frustrating.
But the goal, David had a fantastic idea of making that sort of a community project within the various user groups. So if you're not a professional developer or not an experienced developer and you'd like to work on a project where you can have some structure and some code review and hopefully one-on-one paired programming maybe with professionals, then that's a good spot for you. And if you're a professional and you want to help out people who are trying to get into the community and help provide a little bit of structure to this project, that's kind of the goal there. So Friday, 8 a.m., we're going to just sit down and kind of, I think, come up with an MVP and sort of formalize what the go forward plan is. At Indaba Coffee, I didn't know if you meant Riverside or Broadway. Either, do you have a preference?
No. Where did we were at the one that was
Broadway has free parking, that it does. I always pay when I go to downtown one, it hurts me.
Probably want to go by the.
It's across the river, yeah. Does that work for you?
Yeah, that's cool. Yeah.
Okay. David, does that work? Broadway?
Yeah.
All right, so where we do coffee and code normally, just we'll meet there. Maybe I'll bring a whiteboard because I don't know if they have any, but I've got a big whiteboard. So I'll just walk in and be like, hey guys. So yeah, that's this Friday, 8 a.m. Broadway. I just put it on the meetup event calendar and I'll add the location and I'll send an email out about that.
You guys can be there from 8 till.
Probably, I plan for about an hour. If we go longer, it'll be, I don't know, probably about an hour. Did that answer your question? Sorry.
I'm trying to find a way to like sneak in between other stuff like that going on, but
Yeah. I'll probably,
time, so it's one of those where
yeah.
let's keep this, can I move this meetings around?
I will add a, if anyone's interested, I'll add a remote Teams or Zoom link if you just want to listen in or you've got stuff going on and you want to join remotely. Yeah, I will add that. Well, I guess you'll have 40 minutes of Zoom call unless I pay them money. It looks like it did.
Yeah, my Zoom link died. It's like right as I figured everything out.
I can
Dead.
do that if you want to show it.
No, that's fine.
Yeah, thanks again to Seth and Michael.
I don't know. Does anyone care about the JavaScript part or no? That's fine.
Not working, but I felt like that.
Okay, throw it back up and we can talk about it a little bit if you want. But oh really? Maybe I can start one. Got him. Maybe I can start one.
Maybe if you're interested, you can just show off your computer.
Okay.
Unless everyone wants to see, but people got to go.
Or you can just leave. That's fine.
Well, maybe break for 7 minutes, and then if you want to see the reaction, once my Zoom buffer ends.
There you go. I just sent you a link.
Oh, you sent me a number?
Yeah. Yeah. Yeah, that's fine. It's all, so I have a public repo on my GitHub called .presentations, and then all of my Spug content's in there. So feel free to download it and run it yourself.
What's your GitHub?
mg.dev.
I'll add it to the, or mine. And I'll send it to Facebook too. Is this, did I do the right thing?
Yeah, you did. I just got to admit it.
Thanks everyone for hanging in there with our
Yeah, sorry about that. That's always a bummer.
It's never happened. Anywhere, right?
Okay, we're alive again. We got another 40 minutes. There we go. And this one to this one. Buckle up, guys. Okay, so as we demoed in the test suite, we were able to make API calls to our microframeworks. And basically what this does is this is just a JavaScript client that does the exact same thing. So if we can go down and select Flask, for example, it just takes a name, this description, that, hit submit, and it saves it to our list of items. So that list of items is just saved on the database somewhere. We can go through and change values to fizz and buzz. We can hit this little checkbox to see if it's done. You go ahead and refresh the page. Everything's saved, everything's synced. Because we're making API calls based off of every event that's happening in the client, saying, okay, I changed the value. We're going to push that to we're going to patch that to the data to the web server, and then it's going to return either a 201 or a 204 based off the response. So that code looks like this. This is written in Solid. I'm not a React guy. I tend to favor Solid. The mental model just makes a little more sense to me. Basically, we're just adding we have an add item component, and then for each of the items that we're looping over in our store, our data store in this case, where's our data store? For each of the items, it should be right here, yeah. So in Solid, you have this concept of signals that allow you to change data, and then HTML elements will update date based off of the change of that data. So we just create a signal, and then the API call that's going to return that JSON blob is getting stored into the signal, and then we can do things like make an update call, update the data inside that signal, and then all of the HTML elements on the page are just derived from that component. So that's how that works. So in this element where we also have an update function every time data changes, call the update function, and then for each of the items in the store, we're going to return a new item component, which we're going to pass the hook for the update down, and then we're going to pass in the URL that the API is giving us for that RESTful component of the response, being able to actually like hand off URLs that represent components on the server. So we can take that and then render that for each of the little components. So as we can see on our web page, we have a name, we have a description, we have a timestamp, and we have a little checkbox for if an item is done. That's all represented by signals in Solid, and every time that you change a value in the client, it's going to call this sync function that's going to make a new form data. It's going to get the new data. It's going to make that patch request to your framework. Doesn't matter which framework because they all go to the same data set. And then if the response is a 204, it's going to update the view accordingly. So that's the JavaScript front end portion. So very short.
Individual fields, or do you just?
Yeah, I'm patching individual fields. So we could go down to, for example, let's pick FastAPI, for example, item. Here's the patch function that's actually getting called. And it's going to return a 204 no content, and it's just calling this update function with the items and the keyword arguments. And then this update function is going to get me to
Putting the whole first patch.
No, it's actually it's going to, if I go to the core functionality, which is shared between all of them, item.update is pulling the JSON value from the key. It's calling a dictionary update, which is just going to change the individual field, and it's going to stick it back into the database. This isn't exactly thread safe, but whatever. So that's kind of how you can trace what happens on the client all the way down to the database, and then all the way back up. So, hey, what's up, Joe? Oh, you're just waving? Okay, no, you're fine. So, any other questions? No, I could do it in Solid. I'm not a front end dev. So, okay, yeah, that's it. So, and then for fun, just clear items and then just delete everything. So, all right, yeah, thanks for listening. All right, it's nice to know that I wasn't crazy. Firefox is just screwing me over. Well, when I rebuilt the containers, it gave me a new SSL certificate, and then Firefox was like, "Oh, this is a new SSL certificate. You better, security warnings ahead." And I was like, and then I saw that on the page. I was like, "Ah, son of a," forgot about that. So, all right.